Now we will see how the part number 5 can be modeled, that is pin. Okay, so we have to model the part number 5 which is given in this front view here. So they have given only front view. Okay, for the part number 5, that is pin, it is having a head and the rod portion. So head is having circular shape because they have given here as diameter of 25 mm, and it is having a thickness of 9 mm here, and the rod portion is having diameter of 16 mm and it is having length of 96 mm. Okay, and there is a tapered hole here. Okay, and that center of the tapered hole is at a distance of 89 mm from this particular face. Okay, so therefore let's go for creating this pin now. Okay, so I will go to the SolidWorks, go to part. Okay, part layout, and then select the top plane first. So in the top plane first I am going to create the head of that pin. Okay, so head of the pin looks like circle, so I am creating a circle in the top plane, and it is having diameter of 25 here. So therefore I am going to give the diameter as 25. Once it is done, keep it in isometric view. Okay, and then go for feature extrude. Use the extrude option for adding the material within that circle, and we need to add the material for 9 mm thickness here. So therefore it should be how much now? It should be 9 here. Give it okay. Then select the top face here, and on the top face of the head create one more sketch, and that sketch should be again a circle. Okay, and this circle corresponds to the diameter of the rod here. Okay, it is having okay, a diameter of the rod of 16 mm. So therefore we can give this as 16 mm. Exit from the sketch, go to isometric view. Okay, so this is the circle that we have created on the top face of the head. Go for adding the material, and the material should be added for a length of how much now? From here the material should be added for a length of 96 mm. So therefore give here the material length as 96, give it okay, and fit the model to the window. Okay, once it is done, now it's the time for creating this hole. But in the front view it looks like okay, so a simple hole with diameter of 3 mm, but it is not correct because this particular hole will be occupied by, okay, this particular hole will be occupied by this cylindrical taper pin given in part number 7. Okay, so this is the cylindrical taper pin with a maximum diameter of 4 mm and length of 30 mm, and okay, this face, okay, the cylindrical surface will have a slope of 1:30. Okay, so therefore since this taper pin will occupy this hole here, this hole cannot be a straight hole. Okay, or it cannot be this hole cannot be cannot have uniform diameter. Okay, from front face of the rod to the back face of the rod. Okay, so therefore what we need to do is instead of creating a straight hole here, we have to create the tapered hole. So when we go for creating a tapered hole, okay, so that tapered hole profile should match with this pin profile. Okay, so for that reason what I do now is I am going to select right plane now. So I will select the right plane, and I will select the sketch option on the right plane, and I will change the view to the right view. Okay, by doing this now I am going to construct okay, I am going to construct the profile of the pin, upper profile of the pin. So the upper profile of the pin will be created. Okay, the meaning is that okay, when we create upper profile of the pin, we can go for using revolve cut option, and we can remove the material okay about this axis of the pin. Okay, because you need to remember this particular hole should have the same profile as this taper pin. Okay, so therefore this taper pin fits into the taper hole here. Okay, so the profile of this pin should be same as the profile of the hole. So therefore what I do is I will create a profile here. Okay, this profile is looking like this. So the upper profile of the pin will be created like this, and then what I do is I am going to select the midpoint of this line, and I will select the origin. These two will be aligned now by using vertical relationship, and they have given somewhere here this tapered hole is at a distance of 89 mm from this face. So therefore I am going to define the distance between this line and this face as 89. Okay, the profile has little bit changed. Okay, so I can go for dragging this, I can recorrect. Okay, so I can change the view like this. Okay, so this is how it looks. So now this particular edge is at a distance of 89 mm from the which one end of the pin. Okay, then it's a time for giving the diameter. So this particular diameter here, okay, so should be, so you need to remember this, we are trying to create a tapered hole, and that tapered hole should match with this taper pin. So this taper pin is having diameter of 4 mm, maximum diameter of 4 mm. So the meaning is that the whole okay, the radius, okay, since we are creating only half of the profile here, we have to enter the radius. So therefore, so the maximum radius here can be 2 mm, and the slope should be entered here. Okay, how to enter the slope? So you can it can look like this. So we can drag this something like this. Okay, so now the slope of this line should be entered, that is vertical distance between this point and this point should be given as. Okay, so for this particular line, for every 1 mm for every 30 mm length, 1 mm height should be decreased. So here the length of this line is 30, therefore 1 mm height should be decreased like this. Okay, and then let's see what else we need to do. So when I try to move this particular point, so the width, okay, so the length is not constrained, so let me go for constraining this as 30 mm length. So once it is done, you can see we have created a profile wherein there is a horizontal line of 30 mm length, and the right side height is 2 mm, and this top line is having a slope of 1:30, and that we have defined with 1 mm height and 30 mm length here. You can see 1:30 ratio. Okay, so the sketch is fully constrained now. I will come out of the sketch plane, and I will keep it in isometric view now. Okay, so this is what we have created. Now I will go to the features, and I will go for I will go for revolved cut now. Use the revolved cut option and choose this bottom line as the axis. So select this one and then click on OK. So once it is done, you can see now, so tapered hole is created. So you can, if you want, you can keep it in isometric view, and you can go for taking the section. Okay, so you can take the section instead of taking the section on the front plane, take the section on the right plane, then give it OK. Now if you try to keep it in right view, okay, so if you try to keep it in right view, now you can see we have created a tapered hole. Okay, so this is how we can go for creating a tapered hole. Okay, so then close it, close the section and keep it in isometric view again. Then save the file as part number 5, that is this file should be pin. Then it's the time for creating the next part now, that is collar. So creating collar is very simple. It is like a hollow disc. Okay, so hollow disc with a thickness of 10 mm and outer diameter of 25 mm and inner diameter of 16 mm. So for creating this, I'm going to use the top plane. Select the top plane, then go for creating sketch in the top plane. Then select circle command. Draw 2 concentric circles first. Okay, for the outer one, give the diameter as here 25 mm. So outer diameter should be 25, and the inner diameter of this circle should be how much now? 16 mm, as it's shown here. So it should be taken as 16 mm. Once it is done, okay, so exit from the sketch plane, keep it in isometric view, then go for adding the material between the 2 circles, and when adding the materials, add the material on either side of the sketch. And what should be the height now? Height of the collar should be 10 mm, or thickness of the collar should be 10 mm, already entered here. Give it OK. So once it is done, we need to also make the tapered hole here. So as it can be seen in the top view, okay, so it is a tapered hole. Okay, so again this particular tapered hole should match with the outer profile of this, means the inner profile of this tapered hole, okay, which is made here, okay, should match with the outer profile of the taper pin here. Okay, so this is the outer profile of the taper pin. So similar to how we cut the, which one? Tapered hole in this pin. Okay, so in the same way we are going to cut the we are going to make the tapered hole even in the collar. So how it can be done? So let me show. I'm going to select the right plane, go for sketching in the right plane, keep it in right view. Okay, so then what I do is I will select a line command. Okay, so aligning is somewhere here. I'm going to draw one horizontal line first, then one vertical line, then again inclined line, then this. Now I'm going to give the length of this line as how much? So 30. Okay, so then what I do is I will select the midpoint of this select the midpoint of this line and this origin. Okay, and then make them as vertical, okay, vertical, and then what I do is I will also go for bringing, I will also make those two as horizontal, okay, so that it can coincident now. And now what I do is I will add the dimension to the right side, okay, here vertical right side vertical height will be given. So we need to give which one now? So it is 4 into 30 means the maximum diameter here is 4 and radius will come as 4 by 2, okay. So then I'm going to give the slope of this line. The slope of this line should be how much? It is 1 by 30. So 1 by 30 means here in this case slope is 1 by 30, but we want to know what is the decrease in height when we move over a length of 30. So therefore it will come as 30 by 30. Okay. So you can take like this, then exit from the sketch. Once you exit from the sketch, you can see this is the profile we have created. Then go to the features, go to the revolved cut now. Use the revolved cut and use the axis of revolution as the bottom line. So select this bottom line and go for cutting the material. Okay, so now you can see how the material is cut. So here the diameter is less, here the diameter is more. Okay, so and if you want, you can take the section now on the right plane. You can select, you can take the section on the right plane and you can see here. Okay, so as we move from left side to the right side, the diameter of the tapered hole is increasing. Okay, so this is how you can take the section. If you don't want, you just click on this section view again. Okay, sectioning will be closed. Okay, so save this in isometric view. So part number 6, this is the collar. So the modeling of collar is over now. So and we need to create the last part, that is a taper pin. So let's see how this taper pin can be created. So creating taper pin is very easy now, because the same taper pin profile was created twice for making a taper hole in the pin and a taper hole in the collar. So in the same way we have to create the profile of the taper pin, but here instead of cutting we will go for adding the material. Okay, by using revolve option. So I will use part, okay, then select the which plane, we can go for selecting the front plane now, okay, and then sketch. So I'm going to select line command, okay, and I'm going to draw one horizontal line, vertical line, then inclined line, and then again vertical line. Then smart dimension, give the length of this taper pin as 30, okay, and select the midpoint of this bottom line and the origin and give it as a coincident. Okay, and then what you have to do is you have to give the which one, the radius of the right line as 4 by 2, okay, and we can go for adjusting the values here. So since the top line is appearing in blue color, we can it can have some motion, so it can be dragged downwards so that it can appear like a taper profile. And now we can go for giving the slope here. So this slope should be how much? 30 by 30. Okay, so then close this sketch, okay, and then keep it in isometric view. Okay, we have created this profile in the which plane? Front plane. I will go for using revolved feature now. Use revolved feature and select this as the axis of revolve. Then click on OK. So this will give us the taper pin. Okay, so when you see it from front, it is going to look like this. So when it is seen from the top, again it looks the same. So keep it in isometric view. Okay, and here it looks like they have given some round here on the left face and the right face. Okay, so if you want, you can make it as spherical. Okay, otherwise you just leave like this. Okay, it is sufficient. Okay, so I'm going to save this as part number 7 now. That is taper pin. So this completes the modeling of individual parts. Okay, all the 7 individual parts of the universal coupling assembly. Okay, next we will look at how these 7 parts can be assembled together and how we can get the orthographic views.